This conference will now be recorded.
Okay. So, good morning, guys, and welcome back to a fresh new session on credit risk modeling. And we are discussing the interview questions. Today is the third session of the interview questions, right? So, in the first two sessions, we started off discussing about the first session discussed basic statistical methods and probability. The in the next session we in yesterday's session we discussed about the statistical methods, right? Now in your Google Drive the videos are uploaded up to probability theory and distribution, right? And I have shared the reading materials for the documents for up to probability theory till yesterday. So I have updated it with the sampling theory distribution, the econometrics, and the k variable regression modeling framework. So more or less, I have created the framework. Right now, the question that comes out over here is that if you are to prepare for the interviews, right, I will be uploading more videos to your Google Drive over this month. So which will have all SAS codes and everything. But given that we are discussing basic statistical methods, right? You can and you want videos to prepare the module end to end. I will suggest you to go to my YouTube channel. All of you have been a part of this consult. Really grateful for that. So I what I would suggest is you would if you go to risk consult, right? Uh, sorry, I'll just pause this. So if you come to my playlists, right? So there are two playlists over here, right? So one of the playlists that I have over here is the one on credit risk modeling's basic statistical methods, right? So if you come to this playlist, so if I open this playlist, so if I open this playlist over here, right? Uh, so this is the link of the playlist. So in this particular playlist, you will get to see all the videos. So you will get to see all videos with basic statistics, probability theory, right? Normality, then classical sampling theory, testing hypothesis, and so on, right? So you will get to see all these videos over here. So what I'll suggest you is to start preparing yourself with this playlist. So if you go through the playlist that is described here, right, and you have your notes at your end, and also you start referring to the interview questions that we had discussed, right? You should be able to figure out how this. So you should be able to figure out the the questions, so you'd be able to figure out the solution to the questions, how to answer those questions in the interview. So the link to this playlist is the credit risk modeling basic statistical measures. Okay, so Mubashir says that I am not audible or my voice is breaking. Is it the same for everyone? Am I clearly audible, or is it that my voice is breaking? Okay, so please let me know if there is any inconvenience in hearing me out. Okay, okay. So as I was saying, right? So the first set of playlist, the link to the credit risk modeling basic statistics playlist I have shared over here. in this chat box, right? So till I complete uploading all other videos on statistical modeling and all, so I will suggest you guys to go through these videos, right? So which is there so that you can initially have your groundwork ready for facing the interviews, right? Okay, so this is one of the questions. So this is one of the points that I have over here. Okay, now along with this, there are other playlists that I have. So there's another playlist. Yeah. So I have another playlist over here, which is the predictive modeling playlist. So from linear regression, so linear this particular part contains linear regression and time series, right? So so credit risk modeling, predictive modeling techniques. So these two playlists on the channel will help you, kind of complete the development on the basic methods, right? The logistic regression portion is not described here, right? For the logistic regression modeling section, for the logistic regression modeling, uh, there are a separate set of videos which has been shared out with you, right? So if you go to the Google Drive over here, so if you go to the Google Drive here in Risk Console, your 1.1 drive, or in the IFRS 9 section, right? So in the video recording section, if you go to behavior scorecard, right? So there is this folder, the logistic model framework description, which talks about which uses a bank data and discusses the end-to-end execution of logistic regression over 16 videos. So for logistic regression, so for predictive modeling techniques, modeling classification techniques like logistic regression, please refer to this particular link, right? So So basic statistics, central tendency, dispersion, probability theory, sampling theory is playlist one. The second playlist comprises of linear regression and time series. And this particular list of videos on your drive gives access to you on your logistic regression. So these are the three broad links that you require to prepare your basic statistics and predictive modeling end to end. So when you are preparing linear regression and logistic regression, you are simultaneously preparing for the machine learning sections as well. So these are the two sections which discusses, or these three sections will give you a foundation for your basic statistics in econometrics as well as for your machine learning, right? So is this part clear to us? Any questions? Okay, so this is something that uh, these are the basic learning materials that you would require to prepare for these sections. So the questions that we are raising over here, that we are discussing in this word document, in this note, in this word note, you the answers to this you will be able to find it out in these links. So please copy these links and keep it handy at your end, right? So what I will do is from my part then. So there is one more thing that I can do. Do this. So I'll just make your life a little bit easier over here. Uh, questions. Let me create another document. This is links and locations for study materials. Right? So over here, yeah. So while you open up this, so while I open up the interview questions along with it, what we are also going to do is we are going to, okay, so basic statistics and econometrics, links and reference study materials. Number one, basic statistics, descriptive statistics, probability theory, and sampling. Statistical inference theory, right? Document locations. So this is your Google Drive locations, the playlist link, So what I'll do is I'll copy this location over here. So predictive modeling methods. This is command bold, command U. The document locations. So the locations are the same, the sampling and the regression model locations are the same. The playlist link is slightly different. Okay, and when I say predictive modeling methods, I imply the linear regression models and time series models. Okay. And the third point that I have over here is the logistic regression model. The logistic regression model. So for logistic regression model, your playlist link will be you have only the playlist link. So in the playlist link, go to behavior scorecard, open this up. So this is the link. But this is an access protected location because this is your from your content, right? So this is the basic statistics and econometrics link and reference study materials, right? So does this make sense? So what you can have over here is what you can do over here is uh, so you have your documents over here as well as you have the list of interview questions saved one after the other so that you can use both of the documents to prepare. So in one you will have the question list, in the other you will have the documents, the document locations, and you also have the documents provided over here in the drive, right? Are there any questions?
Nothing, mate.
Debojit, Rahul, Shweta, are you able to now? Would you be able to start your preparations on these lines?
Sure, Tanu. Hello.
Perfect. Okay. Okay. So let's get started with the questions that we were discussing. So we have already kind of listed out the key questions till uh, statistical inference, right? So what we'll do is we will continue our discussion over here, and in this discussion we will be focusing uh, on linear. So our discussion today will focus around, or will be, we will kind of be circulating around linear regression and testing hypothesis. Okay. So over here, what we will do is the linear regression model and the testing of hypothesis. So the testing of hypothesis and this entire discussion is provided in this, or will be discussed in this linear regression modeling framework. Okay. Now the question is, the first question that comes out over here is for us. First question that comes over here for us is, what is regression, or why is, or like, what is the importance of regression? The first question that we ask over here is, what is the difference between, now this is a very common question which comes in these statistics interviews, what is the difference between regression and correlation? Now, this is, so basically, if you think about this concept, so I'm not writing the answer in details over here. We will be discussing regression in more details. So, what we are just talking about over here is like, what is the basic difference between regression as and correlation as concepts. So, we are trying to explore this difference at a very conceptual level. Now, when I'm writing a regression equation, right, or let's say when I'm trying to assess correlation, and I have two variables. The first assumption for doing a correlation or a regression is that the two variables, the first assumption over here, and that is the similarity between the two, both of these are applicable for quantitative variables. So these two variables, so they are applicable not on qualitative variables. Only when you have qualitative variables will these be applicable, right? So x and y both has to be numerical in nature, right? So they cannot be applied on, categorical, like on character variables. The first thing is that applicable for, or both regression and correlation are applicable for quantitative variables. Now, this is something which interviewer would always want to know. So basically, when these kind of questions are asked, the difference between correlation and regression. So we initially start saying that regression assesses the causality and correlation, the association between two variables. No, the first. So when you are asked questions like these, you need to structure the answer, right? So you need to first mention that both these two methods are methods to assess or to analyze the relationship between two quantitative variables. So they are applicable for quantitative variables. The next question is the objective. So what is the objective of these two variables? Of these two methods? The objective of these two methods is to assess the relationship between two variables, between two quantitative variables. Right? So now the question is the difference between regression and correlation lies in the type of the relationship that they assess between the two variables. So the type of the relationship which is assessed is different between regression and correlation, right? So how does that happen, or what do we do around that? So the first thing that happens over here is type of relationship assessed. Regression assesses the causality between the two variables. So the question that it tries to answer is if x and y are two variables, or they're continuous variables, then does x cause y? Does y cause x? Right? Does x cause y? Y cause x? Now, the nature of the causality assessed over here is unilinear or unidirectional causality. The nature of the causality assessed is unidirectional causality. So, this is something that we have over here. So, first, what we have is regression. So, in regression as a method tries to explore the causality between x and y. That does x cause y or does y cause x? But what it does not answer is if there is a two-way causality between x and y. So the nature of the causality which is assessed is the unidirectional causality. So I'm trying to assess whether x is causing y from left to right or from right to left. So that is something. So that is what is the uh, relationship between x and y that they look at. Right now, that this is a limitation of the regression framework, that if x is causing y and also y is causing x and there is a feedback pattern, then then it cannot capture that two-way causality, thereby resulting uh, in an inefficiency. Right? To solve this problem, we require simultaneous equation models to solve those problems. Right? So, but over here, what we try to assess is when x is causing y or y is causing x. Generally, the independent variable is labeled as x, and the dependent variable is labeled as y. Clear? Okay. Now the next question that I have over here is, or the next point that I have over here is correlation. So correlation, as a what type of relationship does correlation talk about? Correlation assesses the association of the two variables. So if x and y are two quantitative variables, then what correlation does is that what is the direction of, then correlation checks if x is increasing, does y also increase? Is x the movement of x about its mean moving in the same opposite direction compared to the movement of y as compared to the y about its mean. So regression checks the causality. So what is then the difference between association and causality? So in causality, you can say, so in causality, you can say that if x increases by 1 unit, what is the corresponding proportionate change in y, right? In correlation, you cannot make such a statement, right? So this is the difference between regression and correlation. So whenever there is a regression framework, in a regression framework, you have a dependent variable, you have a set of independent variables, and what you can check is that if one of the x changes, increases or decreases, what is the corresponding impact of y. So how much of movement in y is caused due to the movement of x by one unit. So that is what is causality. So in causality, you have a slope parameter which measures the change, the rate of change of y due to a unit change in x. And hence, that is what regression is. So regression helps us capture those so that we know that if there are four factors, four variables, what is their respective impact on the dependent variable. So that is what regression is. Correlation just plots the association between two variables, the degree of association. That is, if x is moving, y is also moving in the same direction or not, and if it is moving, how associated are those movements. So higher the value of the correlation coefficient r is, the greater is the degree of association. But correlation cannot tell us that if x changes by one unit, what would be the corresponding change in the target variable, right? So this is something which needs to be assessed, which needs to be looked at, right? So is this difference between regression and correlation clear to all of us? Any questions? Perfect. Okay. So the next question that we would have over here is, okay, now having spoken about regression models, the difference between regression and correlation. Now, another question which is often asked in the interviews, like if I am taking an interview, one of the questions that I ask is that what do you mean by so when when people talk about regression models, right? So the question that I ask, so that is in the asked is, what is meant by a linearity in the relationship of x and y? So if I say that I'm developing a linear regression, right, the question that comes over here is why linear? Like, what is the implication of linearity? Why do you want to have a linear regression in the first place? That's the question that comes out over here, right? So what is this regression, or what is this concept of linearity? Like, what do I mean by linearity in the relationship of between x and y? Yes. Can anyone tell me, like, if I say that x and y have a linear relationship, what kind of a relationship am I kind of trying to project between x and y? So if I say that x and y has linear relationship, so what kind of a relationship am I referring to? So you can unmute yourself and answer. You can put the answer in the chat box. So that's perfectly fine. But it would be great, if we could uh, answer a couple of these questions.
So if we increase the value of x, then y being the y having a linear relationship will also be increasing. Or we can plot a straight line between x and y. the independent
So
and dependent variable.
yeah, so Debajit, what you are saying is the mathematical part of the story, right? I want to understand the intuitive part of the story. So basically, the idea is like this: that if I am explaining this to a client or to a stakeholder who is not a statistics guy, right? So to explain them that if X is increasing, Y is increasing, Y is decreasing. So then they tend to confuse this concept with correlation, right? So when I say that there is a linearity in the relationship between X and Y, so the question that they ask is that why are you fitting a linear regression? What is this linear regression helping me assess? Right? So what is this linear regression helping me? Is that why this linear regression? So to explain this, you need to explain to them that the relationship between X and Y is linear. So I presume that a relationship between X and Y is linear. So if I am fitting this line to this, if I'm trying to fit a regression line to a data, right, I'm trying to check how nicely can a linear relationship approximate the relationship between X and Y. So then the next question that is asked is what is it that you are meaning by a linear relationship? The answer is very intuitive. Okay, so Mubashir says that it is going to be in the direct relationship. Now, even in a non-linear relationship, so if I write a quadratic equation and the sign is a plus, even then the relationship would be in a direct relation. So as x would increase, y would also increase, y would increase, x would increase. But there is something about this relationship. So when I say a relationship between x and y is linear, what do I mean? So what I essentially mean very intuitively is that so what all you are saying is correct. It's absolutely correct. But the way to put all questions to rest is to say that the linearity of a relationship implies that x and y have a proportional relationship. So linearity of relationship between x and y implies that x and y have a proportionate, right? So they have a proportionate or a proportional relationship. So what you are trying to assess over here is that that does x and y have a proportionate relationship, because they have a proportional, because you're writing a linear regression, right? You're trying to test whether or how nicely a proportional relationship between x and y can capture the so how nicely can it capture the what should I say? So how nicely can it capture the relationship how nicely can a proportional relationship between x and y can capture the actual behavior in the data set, right? So based on the data set, does x and y have a proportionate relationship? Because they have proportionate relationship, so therefore the slope of of a regression linear regression equation is always constant, showing that this so basically if I write a y equals to mx, so then y by x is equal to m, that m is the constant of proportionality, so implying that x and y have a proportional relationship. And when you are fitting a linear regression line, you are trying to justify or you are trying to capture how well a proportional relationship between x and y can represent the original or the true behavior of the data. Clear? So, is this question clear to us? Okay, perfect. Now the next question that comes over here is, so I have defined this linearity in the relationships, right? I have, okay. Now the next question that comes over here is for linear relation, for linear regression. Are the and this is a must question that everyone would ask, right? So the first question that anyone would ask over here is that now if it's a lenient interviewer, right, he would ask, what are the assumptions of linear regression model? So, what are the assumptions of a linear regression model? Right now, another important variant of this question is what is the most important form, or what is the most important assumption? So, what is the most important assumption of the linear regression model? Right. So, this is a very important question. Now, to answer this question, right? So, the assumptions are listed in detail. So, I will be discussing linear regression models with you when we are discussing IFRS 9. So, I'll discuss them from the scratch. So, but till then, you can go through this video and you can try to get a hang of it, right? So this is another important question. What are the assumptions of the linear regression model? Now, while we talk about the assumptions, right? So there are multiple assumptions. So there are 7, 8 assumptions of the linear regression model. However, we will be, so what is the most important assumption of the linear regression model? So we will be discussing that. So there is an assumption of the linearity of the parameters. So it says that the model should be linear in terms of parameters, though not necessarily in terms of variables. Because if in terms of variables, if you have non-linear variables, we can always transform them into linearity. However, if a parameter is non-linear, a parameter of a distribution is non-linear, then it is not really possible for us to convert that non-linear parameter into a linear parameter. So the model has to be linear in terms of parameters, though not necessarily in terms of variables. So among the key assumptions, The first assumption that I have over here is that the independent variables should be non-stochastic in nature. The second assumption that we have over here is the uh, the model should be linear in parameters, though not necessarily in terms of variables. Okay. The third assumption is that the error terms, or rather the residual terms in the model should be a white noise. The independent variables should not have any linear association between them. Now, these are the four broad assumptions which a linear regression model should have. Now, apart from that, obviously there are, like other assumptions. Like if you break down these assumptions, you can get even more assumptions. So, so when I say that it is white noise, it means these are the error terms should be identically independently distributed with a mean 0. In the model should be white noise and they should identically independently distributed with mean 0. Right? So these are these are three basic questions. If you are giving 10 interviews, out of this, 6 interviews are going to ask you these three questions, or any two of these three questions. So you will be getting these questions, right? Now comes the next part. From here, I move on to understand the next set of questions. Now, my question over here is, okay, so up to this point, are there any questions that you would like to ask, or anything that I could have missed out?
Tanmay, can you please explain that second assumption again? I mean, in terms of parameter and
Yeah.
not
So the
necessarily variable.
yeah. So what it essentially says is that the model variable should be linear in parameters. So basically, if I'm writing a y equals to mx plus c, so m is linear, right? So let's say I'm writing an equation y equals to m square x. Now m square x means so in the m square, so the distribution of this variable of this parameter m is non-linear in nature. So if the distribution of this parameter m of the statistic is non-linear in nature, I cannot convert it into a linear parameter. However, if I have y equals to m into x square, I can always take a log 2 log x and convert that variable into a linearity. But if a parameter is non-linear or has a non-linear distribution, then I cannot convert it into a thing. So I need to ensure that the model must be linear in its parameters. And that is precisely the reason they worry as to why the linear regression estimates are considered to be the best linear unbiased estimates, right? Because what we are trying to do is we are trying to so the estimate that we first prove that they are the linear estimates, they are unbiased estimates, and they are the best estimates. But the first test that you prove is or you try to prove is the linearity, right? So that is something that and that is precisely what is meant by the parameter. The model has to be linear in terms of its parameters. We actually test that whether the parameter has a linear distribution or not. If the model parameters are non-linear or the conditions to ensure linearity do not exist, we know that the model cannot be built up,
Thanks, Tanmay.
right? I will be discussing all these in details, right? But just to create the list of questions first. Okay. Now over here, what we'll take a very quick case over here, right? So let's say the credit limit increase. So a CLI to be granted to a customer, is a function of or is considered to be proportionately related to the utilization, right? So I'll say the utilization, right? Now the analyst develops a equation of the following form: CLI is equal to A plus B dot utilization, right? So the analyst develops an equation of this form. Now, based on this, the following questions arise. The first question is that does CLI and utilization have, or does CLI depend on utilization? So let's say the equation is something like this, right? 0.05 is zero point 0.1 star utilization. So does CLI depend on utilization? Now, the question that comes over here is that if someone gives this equation to me as a case and asks me that CLI depends on utilization or not, so then how am I going to answer this question? Now, to answer this question, there would be two aspects. First is step one will be so step one will be assess if the the coefficient of causality, also known as the regression coefficient, is statistically significant. Step 02 is assess if the sign of the causality is intuitive or not. So these are the two things that we need to look at. So first is that assess if the coefficient of causality is statistically significant. Assess if the sign of the causality is intuitive or not. Now, if I can answer these two questions, then I can then I will be in a position to address whether this whether this relationship does CLI depend on the utilization or not. So first I need to assess whether it is statistically significant, and then I need to assess whether the causality is intuitive or not. Now, first of all, let me start with the second question first. I want to assess if the sign of the causality is intuitive or not. Now, the first question is that comes over here is how do you define utilization? So, utilization is nothing but the balance outstanding divided by the limit. The balance outstanding in a given month divided by the limit. So it shows that what proportion of the total limit has been used up by the borrower. So higher the utilization of the card on a card, along with other factors remaining unchanged, right? A bank will be tempted to give give the credit, give a higher credit to those, or to give a higher credit limit increase to those borrowers who are who are more in a position to use this card better, right? So the more you use the card, the more the better will be the credit limit, the higher will be the credit limit increase, right? So so higher the utilization is, so for every unit increase in utilization, there will be some increase in the credit limit, credit limit that the borrower, or there will be some impact on the increase that a borrower gets on the credit limit. So over here, the sign of this causality is intuitive. Since banks will be interested to give higher lines of secondary credit to borrowers who utilize their cards to give higher lines of secondary credit to borrowers who utilize their cards more on a given cycle, right? So this is how we would assess the intuitiveness of the signs, right? And we would know that yes, there is no problem in this, in the sign. So the sign is intuitive. Now the next question that comes over here is that how do I assess that whether the, or so how do I assess for the statistical significance of this of this model, or how do I assess the statistical significance of the regression coefficient, whether the regression, or whether the coefficient is statistically significant or not. So for doing that, what we are going to do is we are going to use a simple t-test. So there has to be a test of hypothesis which needs to be performed, right? A statistical t-test is performed. Now, this typically leads us to the question on testing of hypothesis. The question is, how do you perform this t-test? So I will initially set this test up as, what I want to find out is b is equal to 0 versus b is not equal to 0, where H0 is the null hypothesis. This is the alternate hypothesis. Okay, so the next question that follows from here is, how do you define a null hypothesis? So basically, what we are trying to do over here is that I want to set up a statistical test, and to set up the statistical test, I'm setting up a null hypothesis, right? And the decisioning rule is something like this, that if P is less than alpha or A, H naught is rejected at 5% level of significance. Now the question is, we have to define what this P is, what is this less than A, the level of significance, the level of significance is being defined as A, right? And A is taking a value of 0.05 because the level of significance is treated at 5%. So basically, the next questions that would follow from here is, so once you get into this question, from here they'll take it up, or from here a deep dive generally happens, where the interviewer wants to try, where the interviewer tries to understand your concept of understand of your uh, hypothesis testing. And there are four questions which follow one after the other. How do you define, do you interpret a null hypothesis versus an alternate hypothesis? Okay. What is type 1 error? What is the key difference between the level of significance versus the p value? How will you calculate? How do you calculate the p value? Right? So do you need to calculate the level of significance? So these are some of the questions that will come across, right? Uh, what is the difference between okay? Another question which generally comes is, interpret the T statistic and the F statistic. Explain the difference of their usages. Now, these are a list of questions which immediately come up when you enter this question of uh, testing. So, the moment this kind of a case comes up and you enter into the question of testing hypothesis, these are a few set of questions which directly trigger for the understanding of testing hypothesis. Right? So these are the questions. So these are the kind of questions that will generally be coming up. Now, what we need to do is we need to build this portion up, right? The linear regression model and the testing of hypothesis, and we need to frame an understanding. So while we are doing IFRS 9, so in IFRS 9 there will be a lot of applications of linear regression. So after we finish, so after finish discussion up to point in time PD, which you've already begun, the next thing that we are going to do is we are going to study the modeling methodologies over there, right? and we'll try to study them through SAS. And then we'll go ahead and we'll try to assess the relationship between pointing time and TTC/PD as I had explained yesterday, right? So these are some of the basic questions. Now, talking about linear regression testing hypothesis, we have covered more or less all the questions, all the key questions that can come up, right? We need to write the respective responses. So I have not written the responses over here because we have not discussed linear regression till now. So when we discuss linear regression, I will keep on coming back and I will keep on framing I will keep on putting down the answers to each of these questions and thereby taking this question answer list to a more to a larger set of completion, right? So, so with this, we come to the end of the list of statistical questions. The next class, when we move, and we'll start discussing questions on model development, right? So, model development and validation. And from there, we'll go to talk about regulations and guidelines, where we'll talk more about IFRS 9, list the questions on Basel, and then when we are doing BCBS, we'll cover that part up, right? So that's the way we are going to work with these set of questions, right? So we'll have our interview list of preparations as well as we will carry on parallelly with these concepts, right? So thank you guys. Thank you for your time today. Let's take a pause. Let's take a pause here for this discussion session and we'll reconvene in the next 5 minutes with the IFRS 9 sessions. Thank you.